Marcos and Yoran. And now we have the talk about the internals of SMW and especially about performance. That is done by Nischay, who is a former Google Summer of Code developer, and now he's, I think, part of the team.
Yeah, happy. Hi everyone. So I did this Summer of Code project under the Wikimedia Foundation, which was sponsored by. Sorry, just forgot that. Yeah, this was my Summer of Code project. It was called Green SMW. It was under Wikimedia Foundation, and the name was pointed by Marcus, school name, and it was funded by Google. So I'll show you the proposal. The proposal was to, sorry. Okay. Yeah, so like to identify the major bottlenecks in SMW's store relational store backend, and then improve wherever you can identify and then improve them. So there were lots of like stuff that were low hanging fruit, and then like my mentors, Yaron and Marcus pointed out most of them, and then like they helped me, guided me, and then I did a lot of this refactoring stuff, and then okay, so I'll move over to what are the problems with the old store 2. So we had lesser table structures, the numbers, strings, boolean, URI, time, all of these were like stored in the one same table, so there was a lot of performance problems because of those. And then like you have to add new stuff like maps, semantic maps were adding coordinates, so it was really difficult to add those new stuff. And then we also had like complex code which was like when we are getting the property values from the SQL database, it was really complex, and then sometimes there could be errors in there, and like it was difficult to debug. And so we got this new store, we have more table structures, those are separate for all of them. Then you can add more data types like after coordinates, like in semantic maps we are having polygons and stuff, so those can also be headed. Currently we are handling them using blob, but in future there can be more stuff. And then we can use DI handlers, these are extendable, and then you can get more data types. Okay, we have also some special tables for the properties that are highly used, like modification date, that is used on all the pages. So we have special table for those kind of properties. Like you don't need to go and run a query on all the tables, because there is a special table for that. Because if you have a big table with all the stuff in it, then it's like the indexing is not that good. So another stuff, like there were too many SQL reads in one run. You will see many of those select queries if you see the debug log, and then like you will say, oh, all of these are the same query, why are they running so many times? Then there were too many deletes and inserts in the SQL queries. Whenever you edit a page in SMW using the old store and then you save it, you will see lots of SMW SQL queries. Then yeah, you might have not even changed anything. You must just have changed some kind of text which is not part of semantic text. So even those kind of page saves also lead to so many database writes. So what we have now is in-memory cache for all these IDs that we are fetching using the SQL select queries. So it has been reduced quite something around 95%, right?
Let's say
80, yeah. So many. Yes. Yeah, something around 80% is really good. And then we are writing selectively over the tables. Before, what we are doing is like we get all the data in the page that was stored before in the database, and we deleted it, and then we rewrote all the new stuff that we had. But now we have more tables, so we can like find out using hashes which tables are not changed, data is not changed, so we don't write in those tables, and then we only change what is being changed. Like modification date is mostly changed, so we only query the modification date and change it. Other tables we don't need to change anything. So we have faster reads and faster writes. Okay, then we move over to special pages. Special pages like special properties and unused properties, those were really slow, because what they did is like they ran these queries, count queries all over the tables, and those were like O and time. So they were slow, and then if many people are, like many users will be simultaneously checking out your special pages, and it won't be cached that much, so it will take a lot of your CPU. Then now we have pre-computed statistics. Like we have all stored in this one table. We are calling it SMW stats, and then we have the count of all the properties, how much they are used in a wiki. So I think this can be used higher in other ways, but we are still using it just for our special properties. So it does just do a lookup. So this table, it has the count. So we only have to do a lookup in there. Don't need to cache, because it's really easy to do an SQL query rather than so many of them. And this one is very cheap. But then we had some stuff that's left over yet. We couldn't finish in the summer. So we are in the process of fixing them before we release the 1.8. Some of them is like better indexing of the tables. We have some weird kind of indexes, so we are trying to fix them up. And then we have a cool new feature which is like currently implementing. So this diff feature where you can like you have editing a page in Wikipedia, and then you can see the diff, what is been new and what is old. So similarly, you can have something like a diff in the Semantic Wikis where you can see what new property stuff has been added, what has been removed. So this is used in Semantic Watchlist already, but it's doing it on its own. So maybe you can use those. I'll give you a glimpse of the Semantic Watchlist. You can see what properties, like new coordinates got added and some got deleted. So this is a special kind of watch list which can be used. And then, then we are going to stop the support for SQLStore3 in the next minor release after 1.8. Okay, so if you need Store3, how do you upgrade it? So we have two methods to upgrade to Store3. Basically, this is upgrading to 1.8. One is you can use the refresh scripts, and the other is you can use the migration script. So the refresh script is like we were doing from the previous versions when you were switching to new versions. Like you have to do the go to SMW admin and run the setup, and then you have to run this refresh data script, or you can also do it, you keep it doing on a job, and then it will take lots of time. And then, yes, you have to leave it for a while for it to get done. Okay, then the other thing is you have the migration stuff. This you can do is like you have the SQLStore3 running on your wiki, and you can run these scripts which will migrate your data to SQLStore3 tables. These will set up the tables as well, and then you don't need to switch it over before you have the data is already migrated. So you can suddenly then switch it, and you also have to run this script called reset stats. All this does is like it computes the statistics, and you should also run it like sometimes once in a 2 week or in a week, so that your special properties, because it might have some bug in the code, right?
Yeah, well, I mean, so far our experience with that is limited. So as
Yes.
I said, we keep statistics over property usages, and these are updated incrementally. And so if there's an error anywhere in that, it could be that they become wrong at some point.
Yes.
There's some error, and it will not be fixed because it's incremental. For this case, it's always possible to run the reset stats script, which just will query what the statistics should be like. So if there are any problems, you can always go back to
Yes. And anyways, because we have still to make the diff code more better, and so it's still in the process. I think it will get done by 1.8.
Maybe something else I would like to add here is, you said that with the migration script, you can migrate the data before you actually switch.
Yes.
So your data is already there. You can also do that with the refresh script.
Okay.
So actually, all command line scripts of SMW support a parameter where you can say which store they should actually use, and so you can actually refresh a store that you are not using yet. Enter all the data there and switch over when it's working, or switch over on a different site to test it. So this is actually supported.
Yeah, and then you can test this new store without your wiki being not working, and because your store2 will still be there, you are not deleting the tables yet. And then when you are confirmed that okay, the store3 is working good for me, then you can delete your tables because those will have so many MBs of memory. Okay, again I would like to give some thanks to Google for supporting this project, Marcus and Jaron for mentoring me. They were really good mentors, and for Wikimedia Foundation for helping me get here and give this presentation. Okay, thanks for listening. Any questions? We have time.
Yeah. Time for some questions? Yeah.
How do you break compute data for specific?
How do you?
How do you break compute data for specific?
Okay. Yeah, so what we are doing is like when you edit a page, we check all the property values that are new and we make a diff out of them. And so when we are making this diff, we see like, okay, 3 new age properties have been given or some X properties have been given. So we update their counts. We have the count table. So in this way, all the properties have their count stored in a table. So this special properties uses this table, and hence, I think I answered your question.
So that's mainly about the special page, special properties and special unused properties.
Yes.
Unused properties was a major performance headache.
It was using some temporary tables, right?
It was using a big temporary table that it would prune until it has only the properties left that are not used anywhere. And now we can just do a select on a table.
Yes.
Do you have any benchmarks on the performance increases which you?
Not currently.
Repeat the question, just for the
Yeah, he's asking if we have any benchmarks for what we have done on this summer, right? Yeah, not exactly, because we are still we are still trying to improve. There's a lot of improvements still left. So, and most of these are obvious improvements. So, like, we know that what we are doing is really saving some of the computation time and stuff. So, yes, we were trying to find some time for this, but because we still have some improvements to go, we will try to do this after that.
Also, if somebody has a performance problem, or at least thinks that performance could be improved on some data set, it would be very interesting for us to get some benchmark results from on that data, because we did tests, of course, while, for example, when you want to decide how big does a cache have to be to work, well, you have to do tests and see what happens. But we found out that the behavior, of course, is strongly depending on what the pages look like. And we have many improvements that are clearly good from an analytical point of view. We see less things are going to happen, but how much this actually improves in all practical situations can only be tested for realistic data. So any input on this is welcome. So maybe just to sum up, we do not write anything to the database anymore if on edits that only change normal text. So if 90%, as it probably can be in a normal wiki, of your edits are about changing typos, you will have 90% less pure write accesses to your disks. Even if we have to change something, we change it only very selectively. So updating only very few tables, if any at all. Similarly, when we read stuff, we read only very few tables, which actually have data, because we have statistics on that. So in many cases, especially if there's no data at all, we don't read any table. Well, we read one to find out that. So overall, huge reductions. And in the tests we did, about 85% reduction in select counts I got on my machine with data from semanticgraph.org.
So you said that you have many more tables now, for example, property of different types, single table.
Yes.
What if the property type changes?
Okay.
Yes,
Yes, we talked about it. Yes. What we'll have to do is like you'll have to migrate those. Yeah, you have to migrate those property values to the other table. I think the migration script can be used for that. But yeah.
I think that the question was a different one. If you already run on SQLStore3,
Yeah.
now depending on the type of the property, you
Yes.
use a different table.
Yes.
Now somebody changes the property type in the wiki,
Okay.
so the data is in the wrong table. What will happen?
Okay. Yeah, that will still be in the wrong table, if until and unless you migrate it yourself.
No, it will actually, first, various answers. First of all, immediately the data will no longer be found because it's no longer in the right table. This is not a degradation from what we had before, because storing it in the same table does not mean that it makes sense in the first place. So if the type of data was string and you change it to number, there might be many strings that just don't work as numbers, so you won't be able to retrieve them. They will just be filtered out. And this already happens in the old store. Also, we already have different tables. If you change from wiki page to number, these are different tables. So it's not a new behavior. On the other hand, SMW has, for quite some time, automated update processes if you change the type of a property, which will be triggering jobs. And these jobs will go and visit all the pages that use this property one after the other to see again what's happening now, because you can't do that on the database. You can't just look at the table and say, okay, we have this now, so we should have this now. Because some things might not even have been written in the past to the database because they had errors. For example, if you had number before as a type and now change it to string, many more user inputs will actually become usable for that property, which were not numbers but which still work as strings. So all you can do is parse the pages again. It will take some time, but you do it with jobs. So it should be effective in most cases. So yeah.
Any more? Yes.
Okay, just speak up.
Okay. So with the new triple store connection of Semantic MediaWiki, you could think of a scenario where different databases connect Semantic MediaWiki and depending on the queries, depending on the interest, you use a different store, either SQL or a triple store for certain queries. So have you thought about that? Are there any kinds of users who could compete and have this decentralized
Can you get that question?
So the question was, the question as I got it was, since there are many backends, or at least two now, and maybe more in the future, who knows, RDF stores, SQL stores, couldn't we intelligently decide which one to use for which type of queries? Yes, probably. Also, it is difficult to know in advance by just looking at the query which store will be better. But we have actually discussed that only yesterday evening. We discussed Solr as a nice, interesting backend. We will have talks about that tomorrow morning. And Solr is very fast, but it isn't able to do all queries maybe. So it might be possible to have a Solr instance running which gives you very fast access to many queries, but if it doesn't work, you can always fall back to SQL. So that would be something which we could think about. Yeah, Daniel?
In the process of in the process for preparing MediaWiki for Wikidata, we made the extraction of indexable data from the actual page text a bit more flexible. So it is now much easier to create an extension that takes any aspect of any page and stores it somewhere. Basically, you can hook into the parsing process, use any information from the text or from the parser output object, and generate data update objects that then will put that information somewhere. So you don't have to rely on a full you don't have to have a full SMW store if you just want to index some specific kind of data. You could make a very specialized extension for storing just one property in one very specialized kind of store rather easily.
Yeah, actually, that might be something for SMW to look into as well. Having built-in MediaWiki support for having for storing its data in a clean way. Always appreciated to have that. I mean, storing different data in different stores, it might be useful for some applications, but of course it limits what you can do with it because you can't integrate the data. In fact, what we see from users is often a pull in the other direction. We should even store more data, like the page metadata. Now, some people with Solr actually, it might be interesting to store all of the text as well, so you can combine a full text search with an ask query. It's quite doable. I mean, certainly this can be implemented. Some people have implemented similar things. SMW Plus has such a feature, and SQLStore as well, I think. Okay. Yeah. Other questions? Feedback, input. Also in general. Yeah. Okay. So maybe Eloy can already set up and.
We're gonna for the benchmarks.
Something I want to say in any case is we are close to releasing this.
Yes.
we still have some things to look into, to do testing, to be sure it's really working, but most of the things are pretty stable. And so if you want to test it a bit, it's a good time to do so. We would appreciate feedback very much to see where it breaks, if it breaks. And as we said, you can always easily go back to SQLStore3. It's not a one-way street if you do that. You can have both of them in one wiki. Okay.